lecture called Physics is All About Moments. It says one way to keep momentum going is to constantly have greater goals by Michael Korda. Like we said, this is the lecture that's introducing you to the concept of momentum. So let's go ahead and get started. The goals are that you be able to differentiate between inertia and momentum. Now, inertia is something that we talked about earlier this year when we talked about force, and you should also be able to distinguish these between momentum and what inertia is. The second thing is we want you to be able to relate momentum to force and motion. So we want you to be able to kind of interplay those two and see where they come from. And thirdly, we want you to be able to use the equation P equals mv, which is one of the main equations that you'll be using in this unit. Okay. Now, in the investigation, what you did is you rolled a car down a ramp and you were trying to figure out how difficult it was to stop the momentum of a car. And what you should have seen is there's a couple of different factors that affect the impact on this particular styrofoam block. Okay, the first thing is easy, it was the mass of the car. If you added more mass to the car, there ended up being a greater impact. Okay, there ended up being a greater impact on the styrofoam block. So more mass equals a greater impact. Okay. Secondly, you should have seen that if you allow the car to move further, so in other words, if you started it here versus if you started it here versus if you started it here versus if you started it here, the further back on the track, the greater the impact. So we're going to say the greater the distance, the greater the impact. I'm going to call it impact. Okay, and thirdly, you should have seen that if you were to take a look at the angle, so if you were to take a look at the angle between the ramp and the ground, as you increase this particular angle, so in other words, as you increase the angle, you also increase the impact. So there's a couple of different things that affect this impact. Now, how are angle and distance related to the speed of a car using kinematics? Well, we've talked about this before with several labs that we've done before, but as you increase this particular angle, what you're really doing is you're increasing the acceleration of the car. Okay? And as you increase the distance that it rolls along the track, okay, that's the distance that it's accelerating. So these two variables are actually increasing the distance and the acceleration. Well, if you combine that with the fact that you have an initial velocity of 0 to begin with, now you've increased the acceleration and you've increased the displacement or distance as the initial velocity is 0. So really what you're doing here is you're doing two things. You're increasing the time the ball or the car rolls along the track, which is not particularly useful, and you're also increasing, and this is the key one, you're increasing the final velocity. So you're increasing the velocity as it strikes the styrofoam block. So really we're doing two things here. One thing is increasing the mass increases the impact, and the other is increasing the velocity at which it strikes the styrofoam block increases the impact. Now, this impact term is actually what we talk about as momentum. Okay, momentum is sometimes referred to as mass in motion. Okay, so it requires two things. It requires, number one, that it have mass. Okay, that's not a hard thing. Everything that we talk about has mass. Okay, down from an atom all the way up to a universe, everything has mass. Now, the other key thing is that it's mass in motion. So whenever it's in motion, it must have some sort of velocity. Okay, if you have those two things present, if you have mass and you have velocity, then you have momentum. Now, because of that, a lot of times you'll see momentum referenced with energy. So you should be able to say, okay, well, if it has to be in motion, that means what type of energy does it have to have? And I'll leave that for you to figure out, but it's either gravitational potential energy, kinetic energy, or elastic energy. There are situations in which it can have all three, but no matter what, if an object has momentum, it should have one of those. Now, momentum is defined as the product of the mass and velocity. So, since it's the product of those two things, if you increase one and decrease the other, there's really no change in the momentum. So, really, you need to increase both if you want to increase momentum by a great deal. So, like I said, we have to have both mass and motion, and that momentum is a vector quantity, which means that it is very important that you specify the direction. So whenever I say it has a momentum of 10, and you'll see this later, kilogram meters per second, you really should put a direction like east or west or positive or negative. What this means is because it has direction, you are also going to have values like negative 10 kilogram meters per second. And you need to keep those in perspective because these have the same magnitude, but they're in opposite directions. So you make sure you keep that straight and make sure you realize that momentum is in fact a vector quantity. Now, as far as rehashing what inertia was, we said inertia is the tendency of an object to resist a change in motion. So here we have momentum, which is mass in motion, and inertia, we have the tendency to resist motion. So a lot of times people will substitute the idea of mass for inertia. Now, as long as we're looking at it in terms of straight line motion, that works pretty well. If you start to get into things that rotate, that's not quite a great analogy, but it works for our purposes right now. So inertia is the tendency to resist a change in motion. Okay, whereas mass times velocity is the actual momentum. They are different quantities. So inertia does not require an object to be moving. If you have a boat, okay, you can see my great drawing of a boat. If you have a boat that's sitting in the harbor, if that boat is not moving, it still has inertia. Okay, it still has a resistance to a change in motion. So if I come and try and push the boat, it's not going to move very much because it's resisting the change in motion. Now, if you were to have this boat that's sitting in the harbor, it would have zero momentum because it doesn't have any velocity. The momentum equation that we have is P equals mv, where P is actually a Greek letter rho, but it looks like a P. So really you should think of it as kind of a lowercase rho, because P is going to stand for power and all sorts of other things. But this really is momentum right here. Now momentum is mass in motion. It is the unit of kilogram meter per second. Now a lot of times you'll see it as kilogram dot meter per second, and really that dot is just indicating that those two things are kind of multiplied together. You cannot directly measure momentum. Okay, you can measure the mass, you can measure the velocity, and you can calculate the momentum, but as far as direct measurement, you can't really do that. You can also measure the momentum by impacting something that we'll talk about later, but once again, you're measuring the impact and calculating something out. You can't directly measure momentum. Now, mass we've talked about a great deal. Velocity we've talked about a great deal. It's kilograms, it's meters per second. You can measure them with radar and meter sticks and photo gates and all kinds of things, but you should be familiar with all of those by now. It is very important that you realize that the mass needs to be in kilograms. That's a lot of times what people forget to do is they'll say, oh, I have the mass of a bullet that's being fired into wood. What is the momentum? And you forget to change the mass from grams to kilograms. So just be aware of that.